What about a snack? I wonder how long to cook this for. Perhaps I'll leave it for now. What's that smell? Fire! How did this happen? What do I do?
Sir, how did the smoke detector note a sound?
In a smoke alarm, the radiation consists of a man-made silvery white metal, Americium-241, covered by a silver foil. This isotope, with a nucleus containing 95 protons and 146 neutrons, is utilized for industrial purposes to detect the presence of smoke particles or heat sources like the fire in your kitchen. The radiation that is present inside the ionization chamber emits alpha particle radiation and low-energy gamma rays. The alpha particle is simply a helium nucleus that contains 2 protons and 2 neutrons without any negatively charged electrons. The alpha particles that are released collide with the air inside the ionization chamber in order to generate positively charged particles called ions. Inside the ionization chamber, a low-level electric voltage is applied to collect these ions and generate an electric current. This steady flow between 2 narrowly spaced metal plates, called electrodes, work as a conductor through which electricity enters or leaves.
But what happens when the smoke particles drifted towards my smoke detector?
As the smoke enters the ionization chamber, the smoke particles intrude the steady electric current and attach to the charged ions that are then neutralized. The electric current that drops due to the changing rate of ionization reduces the flow between the 2 plates, triggering the fire alarm.
Considering the amount of radiation given off, there must be health risks, right?
Even though alpha particles are eligible to escape the silver foil that covers Americium-241, there is a minuscule risk of gamma radiation exposure due to the particle's incapability to penetrate through the few centimeters of built-up air as it begins to rapidly decline the further away that it moves from the detector. This is evident as the alpha particle has the lowest penetration rate in comparison to the beta particles and gamma rays. Unless human tampering with the detector involves swallowing or inhaling of the metal, the radiation wouldn't be absorbed but would pass through the digestive system. The risk of exposure to the human body is undoubtedly at a minimal level, without causing any health hazard, and can be avoided with the correct disposal of the detector. Supporting its benefits, however, Americium-241 has a half-life of 432 years, meaning that half its atoms will decay at every 432 years. In this case, Americium supplies the smoke detector with a long-lasting life source in comparison to the other radiation sources that need to be replaced quicker, like gamma rays which shoot out bursts of energy. The radiation smoke detector is proved to be the most popular detector due to the inexpensive cost in comparison to the photoelectric sensor, which detects the light level caused by smoke.
So what outweighs americium's use, the benefits or the problems?
When analysing the use of Americium-241 in smoke detectors, it is evident that the minimal radiation hazards threatened to human and natural environments does not outweigh its positive use of detecting smoke particles to alert the fire alarm in order to save endangered lives.
Wow, I never knew how much was going on inside a smoke detector in order to save my life.